Bismillahirrahmanirrahim. Hello students, good evening. How are you? What's up? Are you all well? I missed the file, I'm looking for it. So please wait. I added some new slides to the PDF, and so I'm looking for the new file here. Where is it? Okay, I found it. Yes, this is the file I was looking for. So let me upload it. Yes, it's the file. Okay, what was our last discussion? I'm talking about our discussion in the last session. What was the topic? We talked about it in the last session. Oh, it's too low. The speed of my internet is too low and awful. It's really awful. Can you hear me my voice correctly and clearly? Is my voice clear for you? Okay, good. Policies and mechanisms, yeah, I remember. And I said to you that unfortunately we can only provide mechanisms, not policies. Policies are very ideal. They are not practical indeed. So I'm still waiting for the file. Can you see the PDF file? Is the PDF file shown for you? Neither me. Oh yes, I saw. Okay. So where were we? Scalability problems. Scalability policies versus mechanisms. Yeah. This was our last slide we talked about. Okay. And we want to talk about scalability in detail. We talked about it last session and last sessions indeed. But now we want to deeply talk about it with more details and you know, scalability is the fourth goal of distributed systems, and a good distributed system must have the ability to being scale. However, as you can see, it's written, many developers of modern distributed system easily use the adjective scalable without making clear why their system actually scales. Why? Many developers says that their system is scalable. Okay, it's very good. Our system is highly scalable, and they don't clear why their system scales. Scalability at least has three components. Scalability in terms of numbers of users and or processors. It is called size scalability. Can you remember the definition for scalability? Who can define it? What is scalability? Adding new users and resources to the system, it is extending the system. Extending, not scaling. Scalability, ability to increase input resources without decrease in the performance. Yes, thank you, Zainab. It's the exact It's the exact and correct definition. If we can increase the number of resources or increase the input and the performance is not decreased, so the system is scalable. The system is scalable. So I repeat it again. Scalability. Increasing the number of resources or input in the problem. Increasing in the input of the problem and provided our performance not to be decreased. So the system is scalable. If we increase the number of resources and the performance is not decreased, so this system is scalable. However, at least there are three components in scalability. The first is about size scalability, increasing in number of users and or processors. I mean, number of users and processors or number of users or processors. So if we increase the number of users and or processors and the performance is not decreased, so the system is scalable in terms of size. It is called size scalability. Clear? But it's not the only form of scalability. The other component is about geographical scalability. It means if we can increase the distance between nodes in the network and the performance is not decreased, so it is called geographically scalable. Geographical scalability. If we increase the distance between nodes and the performance is not decreased, so the system is geographically scalable. And the last component of scalability is about administrative scalability. If we can increase the number of administrative domains and the performance is not decreased, again, our system is scalable in terms of administrative scalability. Yes, that's true. That's true, Mrs. Hebe, if I pronounce your name correctly. So, let me talk about these three components more. Uh, about size scalability. Is it always possible to have a size scalability in our system, or our system to make our system scalable in terms of size? What do you think? Is it easy or not? If not, what's your reason? What will happen if we increase the number of users? What will happen if we increase the number of users? or resources, what will happen? I'm talking about these three components in detail. Okay, the first is about size scalability, increasing the number of users and resources. I asked you what will happen if we increase the number of users. Talk about the problems that may occur. Lose performance. Why do you think we will miss the performance? The system is scalable if the performance is not decreased. So, what will decrease the performance in this first component, number of users and processor? At least there are three main problems in scalability. At least there are three main problems in scalability. They are about services, centralized data, and centralized algorithms. These three concepts are the main problems for scalability. So, if we want to make our system scalable, we must solve these problems. What are the problems? Centralized services, centralized data, and centralized algorithms. Here you can see these three concepts. Centralized services is about a single server for all users. If in our system we have one single server that provides services for all users, so it is difficult to increase the number of users. Why? Because if the number of users is increased, since we have only one centralized server, we will have a problem. You know what is it? we have only one single server for centralized services. We are going to increase the number of users that they are using this server, and the problem is what? Yes, we have one single point of failure here. Single point of failure. It means if the server fails, the system will fail. Okay, but I'm talking about scalability here. Okay, not availability. Scalability. We have only one server to provide services for users, and according to a scalability definition, we want to increase the number of users, size scalability. What is the problem? What is the problem? We have talked about it. It is called bottleneck. It is called bottleneck because we have only one server. We are going to increase the number of users, and the requests to the server is increased, so we will have bottleneck. Do you know what is it, bottleneck? We have talked about it. I think you forgot. Yes, أنغى الزجاجة. عنق is neck, I think, yeah. عين نون قاف. Onoq is yeah, the pronunciation is onoq. وبيعة له في عنقي. In دعاء عهد we have. Yes, okay. Have you read دعاء عهد? Do you know what is it? دعاء عهد. I'm writing it here. دعاء عهد. In this dua, we say وبيعة له في عنقي لا أحول عنها ولا أزول أبدا. عنق here is neck. Okay, so centralized services is a problem for size scalability. How can we solve it, or what should we do to solve this problem? It is to distribute services. It is to use distributed services instead of centralized services. It means we can use some distributed services in different locations instead of using centralized service in one location. But however, in some situations it's not possible. For example, suppose that that you are using an application and it's highly secure, top secret applications, for example, or high secure applications. And in this case, it's not a good idea to copy the server in different location and using distributed services. Instead, in this case, it's better to use a single service, a single centralized service in a single location. And in this case, we can provide some security conditions for one location. But if we distribute and we have many different locations, so it would be difficult to provide security conditions for all locations. Is it clear? No? Let me repeat it again. I said centralized services is a problem for size scalability. Why? Because of bottleneck. If we have centralized services, it means we have only a single server and this server provides services for all users. Then if we increase the number of users, because of bottleneck, the performance is decreased. So it's a problem for size scalability. How can we solve this problem? Using distributed services. Using distributed services can positively affect the performance. It means our performance is not decreased by increasing the number of users. But I said to you that it is not always possible. In some situation, we cannot use distributed services. For example, suppose that you are using a secure application. The security is very important for us. So if we have a single server, it's easier to us to provide security conditions, to provide a safe location, because there is a one location. But if we have different locations, if we distribute services in different locations, so we must provide a highly secure conditions in all locations. So it's difficult. In this situation, it is better to use a single server to provide services for all users. Got it? Good. The next problem for scalability is about centralized data. Centralized data, it means that we store all the data in single place, in a centralized location. The example is a single online telephone book. Suppose that all the data are stored in one location. So it would be a problem for scalability too. Why? Because when we are to increase the number of users, again, we have only one location to store the data, and all users want to access this location, and the bottleneck will occur. So the performance is decreased. Therefore, it's another problem for scalability. How can we solve it with distributed data? It means we can distribute data in different locations, not in a single location. We can store our data in different locations. So it can help us to increase the performance. For example, suppose that do you know what the DNS is? What the DNS is? DNS, what is it? Yes, exactly, Mrs. Heather. Yes, DNS, domain name system. Domain name system is a system that it is used in World Wide Web, www. For example, you type in the address bar of your browser, you type google.com. How it translates to an IP and how the location of the server is found. It is translated to some physical addresses. So the DNS provides such service, domain name system. Now, assume that all the domains are stored only in one single server. We have a big world. We have a billion or billions of internet domains. Okay? If we store all the domains and the IP of them and the physical address of such domains in only one single server, what will happen? It doesn't work clearly. Why? Because all the people want to access to this server, and uh, it does not work. So it is better to use distributed data, not centralized data. It means if you want to make your distributed system scalable, it is essential that you do not use centralized data. You must not store all the data in a single server. If you do so, your distributed system will not be scalable. Clear? And the last problem is about centralized algorithms. Centralized algorithms is about some algorithms that is centralized. It's a good example about doing routing, which is based on complete information. Do you know what is routing? Routing, what is it? Routing, R-O-U-T-I-N-G, routing. What does it mean? Yes, routing. Routing is about finding the best path in the network to transfer data between two nodes. Yeah, it's about selecting the best path. For example, suppose that we have 4 or 5 nodes in the network. They are connected together and like a graph, okay. And node 1 wants to send data to node 2, but they are not directly connected together. So we must find a path between these two nodes. What is the best path? The best path is the fastest and is the easiest path to reach. So who can find it? The router. It is called routing in the network. How is routing work? It's based on some routing algorithms. There are some algorithms that can find the best path between two nodes for sending data. So if we use centralized algorithms, again we will have bottleneck. Why? On the internet, for example, we have very different and increased number of nodes in the network, and so finding the best path between every two nodes is really complex. If we use centralized algorithms to find the best path, we will have the bottleneck because there is only one single server that the algorithms are working in this single server. So the bottleneck will occur again. What is the solution? Again, using distributed algorithms instead of centralized algorithms. Is it clear or not? Well, but using decentralized algorithms instead of centralized have some problems, or must have some conditions. What are the conditions? No machine has complete information about the system state. No machine has complete information about the system state. If we have different machines in our distributed systems, no machine has complete information about the system state. It means machine A doesn't know anything about machine B. The next one is machines make decisions based only on local information. It's obviously clear, I think. It's the same as the previous one. And the failure of one machine does not ruin the algorithm. The algorithm is decentralized. Okay, the algorithm is decentralized. So if one machine fails, it does not ruin the algorithm. The algorithm can work properly. And the last one, there is no implicit assumption that a global clock exists. What is global clock in distributed systems? What is global clock? Let me give you an example. All of us, we have a laptop or mobile phone, okay? And also we have a clock on our device. But are all clocks exactly the same? No. Is it possible to sync all the clocks? Sync all the clocks? Is it possible? Is it possible that you have the very exact time on your laptop? The very exact time. Exact. Really exact time. Why it's not possible? You can sync your laptop with some time servers or with some atomic times, for example, atomic time servers. If you sync your laptop with such time, does it mean that you really have the exact time? No, it's not possible. Why? Because exactly syncing is not possible. Because you have a distance, and sending data between two nodes in the network is not always do in the same time. I'm not sure you are understanding what I'm saying or not, but it's not possible to really sync your time with the global time. It is not possible. Of course, we can have approximate time, تقریباً, زمان تقریبی, but not exact time. زمان دقیق نه. این امکان پذیر نیست. It's not possible. So, it's another problem for scalability in distributed systems, because we have not a global clock. For example, suppose in distributed system we have 5 machines, and a server says to all 5 machines that you must exactly execute the program at 12 o'clock. Exactly at 12 o'clock. It's not possible, because the time is not the same for all machines. Yeah, approx time. Well, and what's the solution for this problem? What's the solution? If we cannot assume that a global clock exists, so what's the solution? What should we do? Okay, we will talk about it. We will talk about it later. Here are some techniques for scaling. These techniques are answers for the last problem. The first is about hiding communication latencies. Avoid waiting for response. Do something else. It's a good solution. It means that we can do anything while we are waiting for the response. For example, your computer sends a data to the server, and your computer can wait for response. It's not a good solution. The better solution is that your computer do anything else, do other works, do other jobs. And when the server sends a response and your computer receives it, you can be interrupted. You can be interrupted about the receiving response. Another solution is make use of asynchronous communication. Asynchronous communication, it means it doesn't need a global clock. It doesn't need a global clock. It is called asynchronous communication. It means the machines are not synced. The machines are not exactly synced. Have separate handler for incoming response. I talked about it. And what's the problem again? Not every application fits this model. It means still we may have some application that cannot use these solutions. Another solution is about distribution. I talked about it. Move computations to client, distribution, some data and computation. We can distribute. It's against centralized computation, centralized data. They were problems, okay? And we can use distribution to solve this problem. Moving computations to clients. How? Using JavaScript, for example. You are using a website to register. And so you must fill out a form. Your name, your family, your birth date, and your email, your address. And then this form can be processed in the server-side computation. It's not a good idea because it may occur bottleneck. The server will be busy. So one solution can be using client-side computation. Some of examples are JavaScripts, Java applets. With using JavaScripts on your computer, the format of your email, the format of your birth date can be checked, and you will be noticed if you entered incorrect email format. So it can decrease the load of server. Decentralized naming services, DNS, and also decentralized information systems such as WWW. World Wide Web is decentralized information. It is not stored in one single location. It is distributed. It is decentralized. Yes, divide data. Divide data between different locations. Do not store your data in a single location. For example, if you have a big database, your database has different big tables. You can store each table in one location. Right. World Wide Web, Internet, is scalable. It's a scalable distributed system. It is scalable in terms of size. It means we can easily increase the number of users. For example, the number of users is increased rapidly in Internet. 10 years ago, maybe 100 million people use Internet, but now more than billion people use Internet. So it's easy to increase the number of users in Internet. Why? Because it is scalable in terms of size. One technique that is used in scaling on the Internet is about naming. It is called naming. For example, when you are typing www.google.com, okay, where it is being processed? At the first step, the domain .com is selected, and .com is a generic. So generics are processed in some place. .com, .org, .ir, .net, I don't know anything else. They are processed in some locations. The next one is about the domain or subdomain if you use. So step by step they are being processed in different locations. That is why www is scalable. They are decentralized. They are decentralized. For example, you type imamreza.ac.ir. Okay, the first step is to fetch .ir. So the routing is done for .ir. Then AC is for academic, and then imamreza, imamreza.ac.ir. Each process is done in different location and different servers. Suppose if it is processed in one single location, and what will happen really? Just imagine we have many different domains on the internet, address of internet websites, and if one single location, one single server is responsible to process all of the requests, yeah, you can imagine it. The huge bottleneck will occur and the internet crash. You're welcome. And the other techniques for scaling, we are talking about some techniques for scaling. It's about replication and caching. Make copies of data available at different machines. Copies of data available at different machines. Why it is a good technique to make our system more scalable? If you remember, one problem in scaling was bottleneck. Okay, so if there are many users, we are going to increase the number of users, and so increasing in the number of users may occur bottleneck. To solve this problem, we can make some copies of data in different locations, in different machines, so users can access to different machines instead of one machine. For example, if you search something in Google and I search exactly the same pattern in Google, we can have the same result, but our queries may be processed in different servers. Your query may be processed in a server in Dubai, and my query may be processed in a server of Google in India, for example. Why? Because we have some copies of data in different locations, and it can increase the performance. Also, using mirrored websites can be a good solution. Mirrored websites. It is used usually for downloading files, especially movies. Instead of storing all the archive of movies in one single, and all users must, in this case, must download their movies from this server, which will occur bottleneck, we can have some mirrored websites. Web address 1, web address 2, web address 3, and the user can select which website is better to download it. It's on you. So mirrored websites can decrease the traffic, and so it can solve the bottleneck. Another technique is web caching, and I think we talked about web caching last session. It's about storing some of main data on the client machine. If you open Imam Reza website for the first time, it takes, for example, 30 seconds to load, because all the images, all the templates, all the graphics must be downloaded onto your computer. But if we store some of this data on your cache, on your computer, for example, some of images, the next time that you want to open Imam Reza University website, it is quickly loaded. It is quickly loaded because you have some information in your machine. We have the same thing about file caching at servers and clients. However, there is a problem with caching. What's the problem with caching? Caching is a good technique to make our system scalable, to prevent decreasing performance. But what's the problem with web caching? No, it's not cost performance. It's about synchronization or being updated. If some information is stored on your computer and on the server they change, so you cannot be aware of it. You cannot be aware of it. You must use the old information stored in your computer. To keep yourself updated with the master, you must press F5 button or refresh. With refreshing the web page, all things will be downloaded again and you will be updated. We have the same problem with replicated file servers and databases. If we have some changes in one database, the other copies must be updated with this one. Okay, so synchronization and being updated is one problem with caching and replicated servers. Developing distributed system pitfalls. What does it mean, pitfalls? It means I don't know what's the word in Arabic. It's about trap. False assumptions made by first-time developer. False assumptions that made by first-time developers. For example, suppose you are a developer, you want to develop a distributed system, so you are a first-time developer in this domain. You may have some false information, false assumptions. For example, the network is reliable. You may think that the network is reliable. It's false. It's false assumption. The network is secure. It's false information again. The network is homogeneous. Homogeneous means all the material, all the machines are the same. All the machines are the same. It's homogeneous. But if you think the network is homogeneous, all the operating systems are the same, all the hardwares all the same, it's a false assumption too. The topology does not change. Latency is 0. Bandwidth is infinite. Transport cost is 0. There is one administrator. And these are false assumptions that a first-time developer may assume. So developing distributed systems is not easy. You can see we have not a reliable network. We have not a secure network. We must make it secure. We must make it reliable. Network is not homogeneous. Latency is not 0. So we have latency in our distributed system. We must consider the latency. Our bandwidth is limited. It's not infinite. Good. And about types of distributed systems. Generally, we have 3 types of distributed systems. Distributed computing systems, distributed information systems, and distributed pervasive systems. These are 3 main distributed systems. Let us to talk about it. Distributed computing systems. The first type. Distributed computing system. In fact, many distributed systems are configured for high performance computing. A good example is cluster computing. Cluster computing is a computing system, and it uses a group of high-end systems connected through a LAN. So cluster computing is a LAN. In fact, it is local. It is local, and all clusters can be found in one building because they are using a LAN. They are homogeneous, same operating system, near identical hardware, and single managing node. It is a cluster. It is a simple architecture of cluster. As you can see, we have some computer nodes and one master node. The master is managing all the nodes. We have the same operating system and the same hardware and a LAN, local area network. It is used for high performance computing, parallel computing, to solve complex problems. Please note, it's different thing. Do not confuse with supercomputer. Supercomputer is a one computer containing many processors. But in cluster computing system, we have different computers. Each computer has its operating system, and we use the same operating system for all computers. Also, we use a master computer to manage this group. So there is a difference between cluster computing and supercomputing. Clear? Another distributed computing system is about grid computing. Grid computing is something else. We talked about cluster computing and now grid computing. What's the difference between grid computing and cluster computing? In grid computing, lots of nodes from everywhere. So, in grid computer, machines are not located in one building. It's not LAN, it's WAN, wide area network. So, in this case, again, we have different computers, but they are not located in one building. So, we do not use LAN, we use WAN, wide area network. Also, we have heterogeneous computers here. Heterogeneous means the hardware of computers are not the same. The operating systems are not the same. Yes, no matching. And it's a simple map of grid computing application, then collective layer, then resource layer and connectivity layer, and finally fabric layer. It's architecture, it's layered architecture of grid computing. Okay, it's good for this session, I think, and it's enough. So it is a hadith from Imam Mahdi. We are aware of all your news and none of your actions is hidden from us. I don't know your personality, and in fact, I don't know what's your lifestyle, but creating an emotional relationship with Imam Mahdi will change your life. I say this with confidence. Be sure. Try to talk to him. For example, you can be sure. I can assure you that he hears you, because he is. He is aware of the situation of his Shia, and I recommend you at least every day, try to start your day with a greeting to him. The morning, before the morning prayer, you can put your hand on your heart and say, Assalamu alayka ya Abu Saleh. It's good. It's good to start. If you do it every day, you will feel an emotional relationship with him in your being. When you fall in love, your life begins. So do not forget you're alive, Imam. Do not forget you're alive, Imam. Well, yes, I hope so. Thank you. We will see together next session. Have a good night.